Everybody, welcome back again to the channel. Now, today we want to continue from where we stopped, all right? Now, in this particular video, we want to test out, all right, a few things. Now, we've created a class public route table, and we've associated two subnets that we created to this particular route table, okay? And then we've also associated our internet gateway to this route table. Now, I'm going to go back to subnet. And I'm going to click on each of my subnet, and I'm going to come to action, and I'm going to edit subnet settings. Now, let me quickly say something here. In the last video, I told us that when you create a VPC, you cannot modify, all right, the CIDR. Now, the same thing also applies to your subnet. When you create a subnet on AWS, you cannot also modify the CIDR. So which means if you find out that you have made a mistake, all right, in your VPC creation or your subnet creation, all right, maybe the CIDR is wrong and all of that, you have to delete and recreate the subnet or the VPC, all right, again. But one thing I want to show us here is this. So click on Edit Subnet Settings. Now here, I want to enable auto-assign public IPv4 address because now these two subnets have been added to the class public route table that has an internet gateway connected in its route. So definitely anytime I create any resources using this particular subnet, I want, all right, the resources to have a public IP address by default. Okay? I want them to have that option, all right, by default. So I'm going to enable that and I'm going to save my changes. Now, I'm going to go to the second subnet, all right, and I'm going to do the same thing. So edit subnet settings, enable auto assign IPv4, and then I'm going to save my changes. Now, that is done. So now I can go to my EC2 section, all right, and I mean, let's test out, what we have done actually, right? So I'm going to go to my EC2 section here. I mean, you can see here, I don't have any instances. I really don't have, I don't have a key pair, all right, which means, I have to create a key pair in order to access my instance. In order to SSH into my instance, right? So I'm going to come here to instances, all right? And I'm going to click on launch instances. Okay. Now we are going to do a little tweak here, all right? So I'm going to call these, let's just say HTTPD server. All right. So let's say HTTPD server. And I'm going to just stick to my Amazon Linux, all right? No big deal. T2 Micro, let's stay under the free tier. I don't have any key pairs, so I'm going to create a new one. I'm just going to call these, HTTPD -key, okay? And I'm going to create that key pair, and I'm going to basically save that in my downloads and in my training folder. I'm going to put that there. Now here, under the network settings, I'm going to edit, and I'm going to choose the VPC that we created together, right? So class VPC, and I'm going to select any of the subnets. Whether it's A or B, it really doesn't matter. I'm going to just select one. And here you can see that the auto-assign public IPv4 is enabled automatically because we did that right there already. Okay, so here now we don't have any security group created just yet. And that is what I was trying to tell us, that when you create a VPC for the very first time, you have a default, all right, security group actually created. The security group session is basically a place, all right, where you can actually configure, have access, where you basically configure how your resources are accessed, right? So how do you want your resources to be accessed? Do you want to access them publicly? Do you want to access them privately? Basically, now the security group is basically that space where you configure how, which should access your resource, right? And particularly, what ports do you want to open up? Do you want to open up HTTP port? Do you want to allow SSH access to your resources? All right. And in what manner should that resource be accessed? Should it be accessed by everybody? Should it be tied to maybe a public IP address? Should it be tied to another security group and things like that? So here, I'm going to click on select existing security group. And I'm going to choose, all right, the default security group. We're going to go to the security group later and just tweak a few things here. All right. and I'm going to just come here and I'm going to do something. I'm going to go to advanced details and I'm going to come here under user data. Now, I know we've not talked elaborately on EC2, but I just want to tell us a few things here. Now, already we've learned about shell scripting, right? We've learned about shell scripting. I mean, we did a project on shell scripting already, basically how to do remote execution, things like that. Now here, I'm going to bring in that knowledge here, and I'm going to write a little shell script. Okay, remember, when you're writing the shell script, you have to put your shebang, right? Your bean bash. Okay, now here, I want to do something like, hello world. Okay, I want to basically create, I think, right? So I'm going to copy this and paste it like this. So what I want to do basically is I want to bootstrap my EC2 instance, and I want it to install Apache HTTPD for me automatically, and basically just print out hello world, all right, from the host name, and give me all of the things that I have right here. So basically, I'm going to say sudo. I mean, we already talked about shell scripting. So if you don't know shell scripting, I encourage that you go through the video that was provided already, right? And I'm going to put sudo here as well. I mean, I'm writing into the var directory, so that would probably need some kind of sudo command, all right, as well. Okay, and I'm going to launch my instance, right? Now, when you launch your instance, basically the instance is going to get started, and everything that we provided in that user data script, all right, will be executed the moment the system, all right, starts up. But one thing we need to configure, because we're using a default VPC, right? So one thing we need to configure here is to configure the fact that we want to be able to SSH into our instance, and we also want to access our web server on port 80. I mean, we've not done that configuration just yet, okay? So we need to configure those two things, all right? So I'm going to go to security right here, and I'm going to open up my security group. Okay, and under the inbound rule, I'm going to click on that. Now, the security group has two rules. There's the inbound and there's the outbound, right? The inbound is basically what you want to allow in, all right? And then outbound is what you want to allow out. Now, security group is a stateful firewall, which means you don't have to specify explicitly what should be allowed out. All right, stateful there means you only need to define what you want in, all right, into your resources. Right? I mean, the idea basically is when you give somebody an invitation to your event, the invitation allows them into your event, but there's no invitation that will permit them out, of your event. Okay? So once they come into your event, they can actually leave anytime that they want to leave, right? So with security group also, what we need to define, or what we really need to care about, is what are the services that people can access on our instance, right? What are the traffic we want to allow into our instance. So for security group, we only really care about the inbound rule, all right, compared to the outbound. So here, I'm going to say SSH. Now, the idea here also is that your SSH should not be opened publicly to everybody, right? You want to limit it to your maybe company's public IP address or to another security group. I mean, something that provides some level of security that actually ensures that access to your instance is actually protected and is limited to those who really, all right, should have access to your resource. Is that okay? So I'm going to come here and just say, for now, for the purpose of training, I'm just going to say, all right, 00. And the other thing that I need to do is to enable HTTP as well. Since we're installing a web server, I'm going to say 00 for that also, and I'm going to save the rule. Okay, so now this will ensure that my instance is accessible on the SSH port and also accessible, all right, on port 80. I mean, I can access the web server on port 80, and I can use SSH to log in into my instance as well. So I'm going to come here to details, all right, and I'm going to click on connect and grab my SSH, all right, key right here. And I'm basically just going to go to terminal, right, and try to log in into my instance, right? And you have to navigate to where you have your key downloaded and then copy the SSH command and say yes to basically log in into your instance. So now I am logged in into my instance, all right? And right now I can actually verify if the script was actually installed. So here I can do sudo system ctl status httpd. Okay, and right here I can see clearly that my HTTPD was installed and things like that. All right, and I can also navigate to the directory where I actually, did the echo command, right? So we can go to the var directory, all right, and then HTML, okay, and we can see if the index.html was actually, created. So now I can say cat, all right, index.html, all right, and I can just do that right here, and I can see the information, printed right here. So hello world from this IP address, all right, and I can see that. So from here, I can go back to my instance, all right, and I can grab the public IP and basically put it here and connect. And right here, I can see that it says hello world from my, all right, my DNS address, basically. Okay, and that is exactly what we can see right here. All right, we can see here that the the Bootstrap script that we actually configured, actually worked as we intended. All right, so we can see now that our service is accessible. All right, we can access the web server, everything is working. But now the idea is that this instance is actually public, which means everybody can actually access, all right, our instance. It's a public instance. People can access it, all right, using the public IP address of this instance, right? Now, another thing here that we can also learn, which I really want us to learn also, is now we've seen the public subnet, right? So we have an instance, it is connected, we've configured web server on it, and then we're able to access the web server and everything is working as we intend, all right? Now, let's go and see how to configure a private, all right, subnet. So we can go back to our route table here. We can filter by the VPC, all right, and then we can go to subnet and create additional to subnet, okay? So you create subnet, we select the VPC that we created earlier, and here we're going to call this class, all right, subnet. So class subnet A, and then we call it private, right? Now, again, I've already told us that it is not the name that you give to it that actually makes it public or private. It is the configuration that you do in the route table that actually, tell us whether it's public or it is private, okay? So here I'm going to put it in 2A, and I'm going to create another CIDR for my subnet, and this time around is going to be 32.0, all right, /20, okay? And I'm going to create another one very quickly, all right, copying just a name, and then this will be B now, all right, and this will be in 2B, and the CIDR for this is B17231 dot, that will be 48, right? And 0/20. If you don't understand this yet, I encourage that you watch the video where we talked about understanding the decimal binary conversion or the formula. Okay, that will help you to understand what we're doing exactly as regards the CIDR that we're creating. Okay, so now that we have the subnet created, so the next thing we need to do is to go to the route table and then create another route table for the private, subnet. So class private -RT, so to distinguish between the public route table and the private route table. So here we select the same VPC and then we create the route table. Now here, we don't have any route to any gateway. The route we have is still the local route, which will allow our, resources or instances within the VPC to be able to communicate amongst themselves. Okay, and then for the subnet association, we have this association here. And I'm just going to select these two, all right, subnet. We've already associated these two with the, public route table. So I'm going to save. Okay, but now we don't have any route to any gateway. So, but of course, we want to configure the NAT gateway for this particular, route table, because we've already talked about the difference between the internet gateway and the NAT gateway, right? Any resource that you want to allow to, any public facing resource actually should be in the public route table, and then any private instance that you don't want them to face the public internet, but you still want them to allow, you want them to be able to download something from the internet. Now those will be in the private subnet that has a connection, all right, to the NAT gateway in its route table. Okay, so the idea basically is that when you look at your route table, you should be able to tell if a subnet is public or private based on its association. All right, So if I go and look at the public route table now, and I look at the association and I see the subnet associated, and I go to the route session and I see that the route is configured to connect to the internet gateway, automatically I can assume, all right, that those subnets are what? Are public. But if I come here and I look at the association and I come to the route and I see that the route is pointing to the NAT gateway, I can safely assume also that these subnets are what? They are private subnets. Okay, so the next thing we need to do now is to click on NAT gateway and create a NAT gateway. All right, so here I'm going to just call this NAT gateway class NAT-GW. All right, and the subnet here is going to be, all right, a public subnet. Okay, and then I'm going to choose that because I mean your NAT gateway must be created in a public subnet. Okay, because the NAT gateway, the primary function of the NAT gateway is not to deny internet to your resources. The primary function of the NAT gateway is to allow your instances to have access to the internet while protecting them from the internet. Okay, I mean, in our organizations, we all have connection to the internet, but in your office, if you look very well, your system is not connected using a public IP. Your system is connected using what? A private IP. So something is responsible for allowing your system to access the internet. And that is exactly what the NAT gateway is helping us to do here also. So the NAT gateway still needs the internet gateway to function because I mean your public subnet is connected to the internet gateway in its route table. So the NAT gateway still needs the internet gateway to deliver, all right, on its mandate. Is that all right? So it has to be in the public subnet. So elastic IP, if you don't have an elastic IP already, you can just click on allocate an elastic IP, all right, because I mean your NAT gateway still needs, all right, it needs, an elastic IP. An elastic IP address is an IP address that does not change. Okay, an elastic IP address is what? Is an IP, a public IP address that does not change. Okay, so that public IP address is what the NAT gateway is going to use now to front for every connection to the internet that your private instance make. So instead of the private IP addresses showing up as the IP address making the request to the internet, the public IP address that we are locating to the NAT gateway is what is going to be showing, all right, on the destination side of things. Do you understand that? So I already have one here. I'm going to select that. And I'm going to create, all right, my NAT gateway. Now I can go back to my route table, all right, and click on my private route table from here, click on routes, edit routes, add routes, all right, 00, and come here, and I'm going to choose my NAT gateway and select that. Of course, I need to, I think I have one has been deleted already, so I'm not sure, but let me save changes and let's see. All right, so this is the correct one now. So you can see that it is what? It is active. So the next thing we want to do is to go back to the instances, create another instance, and I'm going to call this HTTPD, all right, private. Okay, and I'm still going to use my Amazon Linux. I mean, it doesn't matter. Okay, so the key pair name is going to be the same key pair. I'm going to edit here, and I'm going to select the class VPC. All right, now I'm going to choose my private. Okay, don't forget private. Select existing security group since we're using the default security group. And I'm going to choose the same default security group. And I'm going to launch my instance. Now, the question you may want to have is that if my instance is in a private subnet, so how do I access it? Right? How do I connect to it? Because I mean, it doesn't have a public IP address. So the question will arise as to how this instance can be accessed. All right, how can this instance be accessed? I mean, we need to figure that out, right? Because it doesn't have a public IP. Even if you choose to enable public IP address for this, but for the mere fact that it is inside of a private subnet that has a NAT gateway configured, you may not be able to access the instance still. Okay, so that brings us to the concept that is called the bastion host. So you have to create what you call a bastion host. Now, already we have a public instance, all right, that has access to the internet. So we can log into the private instance through this public instance, and that makes the public instance a bastion host. Or in some cases, they call it a jump server. Okay, so I'm going to click here, and I'm going to basically I think I've connected to it already, right? So I'm connected to my instance here already. So now what I need to do here basically is to copy the SSH key, all right, that I used for the instance. So I'm going to come here. My SSH key is downloaded somewhere here. Okay, and I'm going to do cat. I think it's HTTPD, all right, keep them. So I'm going to copy this key. Okay, I mean, that's the key that I can use to access my instance, right? And I'm going to come in, I'm going to create, all right, a key.pem. I mean, it doesn't have to be the same name. It is the content of the key that actually matters, all right? So I'm going to paste that here, and I'm going to save that. Okay, okay, so what is it saying? All right, write and save. Cannot open files for writing. All right, so that's some Linux issue right there. So I'm going to quit out, okay, and I'm going, oops, I mean, look at the directory. I'm inside of, look at where I am. I'm inside of the var www/html, and I cannot modify the directory, right? So that's why it's throwing up that error. So what I can do is I can go back to my home directory, and then I can do the same thing right here, okay? So, I mean, that's the purpose of understanding around Linux. I mean, if you don't have that understanding, you'll just be wondering what exactly is going on. So now my key has been saved. And of course, I have to do chmod 400 to just basically keep the key, all right, private. I mean, that's what AWS advises us to do. So now the key is only writable, okay? So now I can come here and click on my private instance, click on connect, go to SSH client, copy what I have here and put it here. But of course, I need to remove the HTTPD at the back, all right, and then connect. So now you can see that I'm able to connect to my instance using its private IP. All right, take note of that. I'm using what? The private IP, because both the public instance and the private one, they belong to where? They belong to the same VPC. All right. So whether it's it's in the subnet A or subnet B, it really doesn't matter. What matters is they belong to the same VPC. All right. So I'm going to say yes. And right now I'm able to access my instance. And if you look at the IP, this is 172.31.61.206. All right. And if you come back here, all right, and you look at your instance, right? The public instance has an IP address of 31.23.207. All right. And this one has an IP address of 61.206. So clearly, they are not in the same subnet. I mean, if you look at the IP, this is 31.23 and this is 31.61. So they are not in any way in the same subnet. But of course, like I said, they belong to the same VPC. So it is easy for us to access, all right, this instance. So now if I do sudo yum install, all right, HTTPD. So I mean, we're testing a NAT gateway to see if the NAT gateway is working. So we can come here now, and I mean, what I see here basically tells me that my NAT gateway is actually working. Because if the NAT gateway is working, there's no way I will be able to download and install what I'm about to install right now. So that clearly tells us that the NAT gateway, I mean, is working. But the only challenge now is that there's no way to access this web server. All right. I mean, the only way I can do that is just basically to say curl. All right. I can just say curl local host. I mean, that would show me, I mean, here it says failed to connect to local host on port 80. All right. Could not connect to the server. Okay. So that can be, you can check your security group for something, but of course, security group port 80 is opened up. All right. But of course, we may not be able to access this instance. All right. Or basically, we can try another thing and then just put HTTP, all right, behind it and do something like this. And right now it's telling us it cannot connect, all right, on port 80. Okay, I mean, it's a private instance, right? But if I do sudo, oops, another thing that we didn't do, remember, all right, remember sudo systemctl status, HTTPD. Now, the HTTPD service is not what? Is not active. That's why we cannot access it. Okay, it's not a security group thing, and it's not because it is private. So for the Amazon Linux instance, you have to enable your HTTPD and start it manually. And that's the difference between this Linux variant and your Ubuntu variant. Okay, so we can do sudo system ctl enable first. All right, enable will make sure that the next time we restart the instance, the service will start automatically, right? So enable and then sudo systemctl start HTTPD. Okay, so now if I go back to the call command, all right, now I can see that it says what? It works. But it is a private IP, right? So I can go to my web browser and put a private IP there. I mean, it's not going to work, right? So that means we need a load balancer to access the resources on this particular private instance. But of course, we have been able to see what the NAT gateway is doing. We've been able to see the function of the NAT gateway, and I believe that with what we have learned in these two videos, we've been able to understand clearly a private subnet, a public subnet, the function of the internet gateway, and the function of the NAT gateway. So now if you go to an interview and they ask you the question, what is the difference between a NAT gateway and an internet gateway, you should be able to explain that very clearly. And when they ask you the difference between a public subnet and a private subnet, you should also be able to confidently explain that as well. So thank you so much, and I'll see you, all right, in the next one. Now, don't forget, all right, to delete your resources. Don't forget to terminate your resources. It's very important. All right, terminate all your resources. Go to your VPC, particularly your NAT gateway. Don't forget to terminate your NAT gateway. So click on NAT gateways. All right, delete this one here. And once you have deleted it, all right, just wait a little while for it to get deleted permanently so that you can also release your Elastic IP. All right, you can go to your Elastic IP from here. All right, select it and come here. You can say release. Now that is after your NAT gateway has been deleted. So once the NAT gateway has been deleted, you can come here and release your Elastic IP. All right, so thank you, and I'll see you on the next.